Saxon Algebra 2, Lesson 2. Greetings, students. I have happy news. After 3 review lessons that are super geometry focused, we're now going to just dive into some algebra. We still have some geometry at the end, but we're going to do some algebra, which many students, I'm not sure, I'm trying to remember if either of you guys have told me. Most students prefer algebra to geometry. And so here we go. The first thing I want to do a review on is negative exponents. A negative exponents looks like that. You know, there's this little minus sign up here that behaves in a totally weird way, and I often call this a trapeze because it swings the base down to the denominator, right? It burns itself off in the process. Once you flip it down, there's no minus sign there anymore, but it flips it down from the implied numerator all the way down to a denominator. Vice versa, if you have a negative exponent in the bottom, the denominator, the downstairs, the basement, the cellar, that trapeze flips up, okay? So the trapeze can work in both directions. Make sure you have this in your notes, your formulas, your cover of your book. It's easy to forget because this minus sign behaves in such an odd way. Not the way we're used to minus signs behaving. So let's just do some simple practice problems to beat that into our skulls. Simplify a 1 over 3 to the minus 2. Okay, so this looks like this one, doesn't it? So we flip it up. The minus sign burns off, and then we simplify. Yay, that's right. Let's try another one. Three to the minus 3. All right, that looks more like this one, right? Where we don't have a fraction to start. So we flip it so it goes down, right? Again, the minus sign burns off in the flip. And this becomes 1 over 27. Yay. Nice, right? Okay, let's try C. I'm gonna slide up a little bit so you can see better. C is gonna throw us another curveball. It's got a minus sign in front of the base. Again, remember, you can't do something like, oh, these cancel out. No, they behave in completely different ways. Minus signs in exponents are like their own beast. So we have to just swing on the trapeze first. So this becomes 1 over minus 3 squared. Notice that I don't change this at all. The only thing I change is I burn off the trapeze. The rest of it just copies exactly the same. Now I'm ready to simplify here. Remember, if I can cover up the minus sign, I do. Then I do this squaring, that becomes 9. And then I add the minus sign back in. I don't want to add it down here because we don't usually, well, I'll do this. It looks like that, right? And then we rewrite it as minus 1 to the 9 with the minus sign floating. As much as I hate numbers that float, AKA mixed numbers, I love a floating minus sign. I don't want it to be affixed to one or the other. So we can just move it out like that. Okay, and then we have one more. I'm gonna squeeze it in right up here so I don't have to turn the page away from this. The last one, it's a variation on the theme. This time it looks just like this, but we have parentheses. Again, the first step, we don't worry about that at all. We just flip that trapeze. 1 over minus 3 squared. Now we can simplify the bottom. This time I'm actually multiplying minus 3 times minus 3, so that's positive 9. Yay! Happy days with negative exponents. Do you like my shadows? It's actually sunny outside. Yay. All right, that's all I have to say about now for negative exponents. Oh wait, there's one more. E. We wouldn't want to forget little e, would we? That's really hard to see. I hope you're not struggling too much. Ready? It's complicated. 1 minus. Look at that. That's a lot going on. Okay, how do we start? Always with the trapeze. The trapeze always gets our attention first. So, remember, it's in the numerator, so we want to flip it down, and we just write it exactly the same without the trapeze anymore. Okay? Now we'll sort out this mess. The 1 is blessedly simple. We cover up the one that we can. This means we're cubing minus 3. So it's minus 3 times minus 3 times minus 3. This is 27. Thank goodness, the number we can do quickly. That's 27. Now let's count up our minus signs. 1, 2, 3 of them. That's an odd number. So this is minus. But when we take that back into consideration, it turns out to be plus. So this ends up being positive 1 over 27. Okay, now we're ready for part C we're up to already. And it's one of my favorites. Rules for exponents. Okay, you've seen my famous chart. John doesn't know about the chart. I made it up without him. But he knows all the information in it. It's harder to print charts in books, you know, in typesetting and all of that. So John doesn't make as many charts as I do. Draw with me. I'll give you a chance to get that far. This is the same chart we've been doing since last year. And we call it Rules for Exponents. Look, I wrote the same thing twice. But I want you to write this chart in your notes, and then I want you to copy it into your book. We'll finish it, and then I'll have you pause me, and I want you to recopy it, so you'll write it twice in a row. I want you to copy it exactly like I'm doing it here. The first rule for exponents is called the product rule. And that rule says, if you've got two bases that match, right, and they each have an exponent on them, you can simplify that by just writing one base and then adding together the exponents. If you're multiplying the bases, you can add the exponents. Closely following is what we call the quotient rule. Remember that product implies multiplying, quotient implies dividing. So in this case, we are dividing the same base with exponents. And in this case, we can simplify by subtracting numerator minus denominator, right? That's kind of logical, if that feels right. All right, and then the third one is called the power rule. It always makes me think of the, well, they were the Power, it's the Power Rangers and the Powderpuff Girls. I blend them together in my brain. Okay, in this one, we have a base. It's already being raised to a power, but we want to raise it to a higher power. The way we do that is we multiply the exponents, okay? If we're multiplying, we add. If we're dividing, we subtract. And if we're raising one power to a higher power, we multiply. Now, notice that these letters are meant to stand for letters or numbers. Okay, they work both ways. So sometimes people get annoyed because I have the X's here. Well, it works in problems if you have X's. Usually we have numbers in our exponents, but later on we're going to get letters and exponents. Ay, ay, ay. So it works for those too. So that we're trying to make this, you know, generic so you can plug in anything you want. Okay, those are the rules for exponents. Pause me now. Copy this into the place that you keep your formulas. I want to make sure you have it handy. Pause and then come back when you're done. Okay, you're back now. I'm happy. That means you've written that chart in your notes. Now we're going to use it. Example 2.2. Simplify. These problems are a pain to write out. Okay, we've got x's and y's, we've got a variety of exponents, we've got a lot of negative exponents, and part of us is thinking, oh, we need to get that trapeze out and start flipping things, right? Because all of these guys need to go to the denominator. But here's a caveat to that trapeze rule. If we want, we can use the product or power rule, product or quotient rule to simplify first before we start swinging things around on the trapeze. So here's what I'm going to do. I'm going to identify all of the matching bases. When I see this one, a new alarm goes off in my head. That's a zero exponent. Do you know what zero exponents mean? It means that the whole thing just turns into a 1. And when we multiply, ones evaporate, right? Because 1 times anything is that thing without any change. So I can just cross this off. So let me put this around here. Don't forget that. Anything raised to the 0 power is equal to 1. Goodbye. So now, using the product rule, I can add these. And this is the way I like to show it in my work. I don't want to try and write it out as exponents because it gets too little. 2 minus 5 minus 4. There is me adding these exponents, right? The minus signs. Oh, wait, not minus 4. I copied the wrong one, right? That's a y base. Let me cross that out. It's plus 5. Does that make sense? Let me write that again. It's 2 plus a minus 5, which I'm showing you that I'm adding it even though it's a minus number, plus 5 at the end, okay? That's just a neater version of what we were doing. And then I can simplify to this by canceling those two. And so the final exponent that goes on my x base is 2. So I'm going to start my answer right here, x squared. And now I'll do the same thing for my y values. Instead of trying to squeeze them little, I'm just going to copy them. And here I'm going to circle. Well, this one now I see as a problem. There's no exponent. So I give it a 1, right? An invisible power means it's a 1. And then here's this one. So I can say it's 1 plus negative 4, and that equals negative 3. So the exponent that goes on my y base is a negative 3, and this is my final answer. It's perfectly fine to leave the answer that way. This is, I think, the way John does it. What else would be fine if you wanted to write your answer with all positive exponents? You could write it as x squared over y third, right? We would just use that as a trapeze and flip it down. So this is exactly the same information. Negative exponents aren't necessarily bad. We don't necessarily need to simplify them, but if you wanted to simplify it, you could write it like that. And very often you'll see John will tell you how he wants to see the answer. 2.3, ready? Oh boy. It's long. Right? There's all of that, but as if that wasn't enough, we have a denominator too. So the way we're going to approach this is we're going to fix the numerator first using I have my notes right here. We'll use the product rule to simplify here. Then we'll use it to simplify the bottom. Then we'll use the quotient rule to simplify them against each other. All right? So first, we will just simplify the top. I like to go alphabetical, so I'm going to choose the x's first. Instead of writing everything out, I'm going to carry it in my head. Here are the x's. I guess I'll just underline them. So it's 4 and minus 10 that I'm adding together, and that becomes minus 6. Now I'll do the y value up here. Let's see, here's a y. Better give him an exponent. Here's a y, and here's a y. So this will be 1 minus 3, that's minus 2, plus 5 is 3. So I've used the power rule to simplify my numerator. Now I'm going to do the same thing in the denominator. Here are the x's, minus 3 and plus 2. That's x to the minus 1. And here are the y's, minus 6 and 10. When I add those together, I get 4. Okay? So that's using the product rule. Now I'm ready to bust out the quotient rule. If the same base is over and above, we subtract them. Now I'll write it out with a little bit more care because I want you to follow it. For the x's, we have negative 6 on the top minus 1 on the bottom. And for the y's, we have 3 on the top minus 4 on the bottom. Notice I'm using my buckets to keep my signs straight because I have minus signs in my values and I have a minus sign in my formula. When you have minus signs in your formulas, that is a sure sign that you want to use buckets. And that's why I switched and showed you the top calculation with a bucket too, because I wanted you to see that buckets are very valuable in this, especially when we're using the quotient rule. Okay, now we're ready to simplify. Minus 6 plus 1 equals minus 5. 3 minus 4 is minus 1. So our final answer is x to the minus 5, y to the minus 1. We can write the answer like this, or as I showed you here, we could choose to simplify those negative exponents, and it would be 1 over x to the 5th, y. We can take out the 1 once we flip it because the minus sign goes away, right? So this works, but now let me show you how, because we have 2 letters, we could get even fancier. We could say, let's leave x up top, but just flip down the y, right? X stays up there. We trapeze the y only, or we could do the opposite. We could leave the y up top and flip down the x. So when we have negative exponents, we have a lot of ways to to simplify our answer, and none of these is more right than the other. Sometimes John will ask a certain way, but sometimes you'll just do what you want to do and then compare to his answer, and you have to be able to move back and forth between these to say, okay, John says this and I say that, but we are saying the same thing. So you have to be comfortable testing your answer to make sure. So he's going to give us practice, and he's going to often tell us how he wants us to present our answer. He's not yet, but he'll get to that. Okay, we have one more to do, and it's using the power rule. The Power Rangers rule. I don't know much about the Power Rangers. My kids were never into those. So I think I need to study up. Okay, ready? It's a beast. That's an exponent. That's just the numerator. I'm going to start with that. I'm not going to copy the denominator yet because there's so much going on here. I want to stop and show you. Okay, one thing I want to point out is that when you're writing these exponents and bases and there's so much going on, make sure you exaggerate the difference between them. Make sure that you can tell in an instant which are your bases and which are your exponents by the size in which you write them. This one was too big and too low, and it was starting to look like a regular number to me. That's why I scribbled it out and rewrote my exponent very distinctly. Even the neatest student who's writing tiny has a very difficult time making that distinction. Now is a time to give yourself a little more space and make sure your bases are much bigger than your exponents. Okay, now these we need to use the power rule, which we can see because we have bases raised to an exponent raised to another exponent. So that's a sure sign that we need the power rule. This one is pretty straightforward, so we'll do it first. We're going to take this 2 and multiply it by that 3. Remember, that's our power rule, right? Have something raised to a power, raised to a higher power, we multiply. Okay. Let's multiply. This becomes x to the minus 6. And I'm just going to keep that in parentheses. I'll put the x here. That x doesn't have an exponent, so I'm going to give it one. Notice that the power only relates to the base that's immediately following it, and the parentheses are usually around it. Okay, I think always. This squaring does not relate to this x. He's outside the parentheses, so he doesn't get to be raised to the power of 2. Same for this y. He's just chilling. He's by himself. So we'll give him a 1. Now, this minus 3 is going to go to both of these bases. Oh, that's so tricky, right? Because they're both inside the parentheses. This needs an exponent, so let's give it a 1. And now we'll go ahead and multiply using the power rule here. This will become x to the minus 3, right? We're just multiplying. And y to the positive 6. And I can put the parentheses around again. I don't really need them anymore, but I'm going to leave them there because they make me feel more comfortable. Oh, that was a lot, wasn't it? But now we're ready to use, so here was us using the power rule. Now we're ready to use the product rule to clean this up a bit further. Because here we have x, x, and x. So let's add those together. 1 minus 6 would be minus 5. Minus 3 more is minus 8, right? 1 minus 6 minus 3 gives us a negative 8. And now we'll do the y's. 1 plus 6 is 7. Okay. Whew, that was good. That was all just the numerator. Now we have to take the denominator. I'm going to leave a little space here because I know that I'm going to come back in and add a denominator, but we'll start with the denominator down here. I'm giving myself plenty of space in the middle here to come back and finish off the problem. Now I'll copy the denominator out of the book. This is when you start wondering what's happening in your life and why are you even doing this? And surely there must be a better destiny for you than to work problems that are so disgusting. Well, at least the bottom looks a little bit better than the top, I think. Okay, good. So, again, we're looking for power rule first. We want to simplify this. This one applies there. That becomes y to the 6th. This guy is by himself. And this applies here, x to the 6th. Oh, okay. That was less dramatic than the first one. And now, look, our x, to use our product rule, Our x is all by himself. We don't have anything for him. These guys can be added together. 6 minus 3 is positive 3, right? The minus comes from the exponent itself. We're adding them together because we're product ruling it. Okay, so now we can bring this up here. X to the 6th, y to the 3rd. And now for our final step, we'll use the quotient rule and subtract where the bases match. Ready? So I'm going to say this. X, it's going to be minus 8 minus 6. And the y is going to be 7 minus, here, I want to put a bucket around the first one too, minus 8 minus 6, and then 7, this one's easier, minus 3. Make sense? And so then we get x to the minus 14, y to the positive 4. That is our final answer. Yay. Now, that looks really good, but when we go to compare to John, I don't know why I like to make that little arrowhead between it. John says that the answer is y to the 4th over x to the 14th. So now we have to compare John's answer to our answer and see if they're saying the same thing. And we see, okay, here's what John did. He took this negative exponent of x to the 14th and he trapezed it down and put it in the bottom. He left this up top. He just put the x base in the basement. That is the same. So yes, those are the same answers and we're right. Make sense? You have to get a little creative here. Okay, 3 of our 4 topics are done. 4 of our 6 problems, examples are done, but we still have more to do. Circle relationships. Oh my gosh, what does that even mean, right? The circles are dating. Okay, these are problems that at first will feel like they're blowing your mind open because we're working backwards through our formulas. Remember that the area of a circle is pi r squared. The circumference of a circle is pi 2r. We're going to use these formulas to work backwards. And notice that they both have an r in them. That radius value connects the 2 formulas. It acts as like a bridge, right, between them. And that's going to be useful in these problems. Okay, let's try example 2.5. The area of a circle is 12.2 meters squared. What is the approximate circumference? Okay, what we're going to do is we're going to take this area, we're going to work backwards through the formula, and we're going to solve to find the radius. Then we'll take the radius and calculate the circumference. Weird, right? So we're going to take the area, and we're going to find the radius, and then we're going to find the circumference. That's kind of a map of what we're doing. All right, so how do we do that? How do we use the area to find the radius? Well, we know that the area is 12.2, and we know that that equals pi r squared. So if we divide both sides by pi, and over here I'll write pi, look, I made that fraction line, I made it like the top of a pi sign. It equals 3.14, right? Then this will cancel out, and we'll get a value for r squared. The problem is now we have to take 12.2, and we have to divide it by 3.14. And that is a little bit annoying. But you know what? Then we have to take the square root of it too. So here's what we're going to do. We're going to use a calculator for this because we're taking the square root. So what I want you to do is grab a calculator. I want you to enter 12.2. I want you to divide it by 3.14. I want you to get a value for that. And then I want you to take that number and I want you to hit, these are all the buttons that you're pushing in your calculator, and then I want you to find the square root button. It looks like that. I would do it and show you, but my calculator is also my camera. So, bummer. And what you'll find is that you'll get a value of 1.97 for the radius. Okay, that's how we solved this. Okay, if you have any questions about this calculation, let me know. But because we're taking the square root of this number, there's no point in dividing this by hand because we have to find the square root of it. And there isn't a calculation to find the square root of a number precisely. So we'll use the calculator to find this value. And then we will move on because now we have a value for the radius, right? We've done this. Now we can find the circumference by taking pi, 3.14, and multiplying it by 2, and then multiplying it by our radius, 1.97, right? These I can do in my head. This is 6.28, right? And so then we can just multiply. I'm going to do it on the next page. 6.28 times 1.97. This we can easily do by hand. Go ahead and do it, and I'll do it, and then we'll compare. There's my answer to the multiplication. Go ahead and check your answer against mine. And then I rounded to 2 decimal places. And then this is the circumference we're measuring in meters. That is our final answer. Okay, because what we did was we found the area, we took the area, and we found the radius, which is right here, 1.97, and then we used the radius to calculate the circumference, and the circumference is 12.38 meters. Again, if you have any problems with this calculation, with taking 12.2, dividing it by 3.14, and then taking the square root of it, right, because this is a square, so then we have to take the square root of both sides. Ask me on the video chat this week. I'll try to remember to ask you. Okay, and then we have one more of these types of problems, example 2.6. And this time we're told that the circumference is 8 pi centimeters. Graciously, our friends are not requiring us to multiply by 3.14, and we have to find the area. So we do the same thing, only in the opposite order. We're told the circumference, we're gonna use that to find the radius, and then we'll use that to find the area, okay? And just to help us remember, I'm gonna write area of a circle equals pi r squared, circumference of a circle equals pi 2r, I want those in front of me. All right, so now we know that the circumference is 8 pi, and the formula is, oh wait, that's an R. I have 2 pi's in them. Pi 2r. Now, this seems really weird when you first start doing it, but we can just divide it by pi. They cancel out. Goodbye. 8 equals 2r. Oh, I just don't want to write that r today, do I? Divide by 2, and we get the radius equals 4. Oh, this is much easier than last time, right? It's because we don't have to deal with the squaring on this side. Okay, now we're ready to do the second half of the calculation. We've got the radius, now we want the area. This is the one that feels normal to us. The area equals pi times the radius, 4 squared. So the area equals 16 pi centimeters squared. Oh, that was much more restful in terms of the math, wasn't it? Thank you, John. Thank you for giving us a nice, easy problem to end with. All right, we are complete. Please go ahead and do all the practice problems. Answers are in your solutions manual, and the odds only on the problem set. Beautiful. Thank you very much. Goodbye.